Hello friends, I welcome you in lecture number 27 on hypothesis testing. In this lecture, we will discuss one more question on F ratio test for equality of two variances. And we remember that if we have two normal populations with population variances sigma 1 square, sigma 2 square, and if we are drawing random samples of size n1 and n2 from those two normal populations, and suppose s1 square and s2 square are the sample variances, then if these two populations are independent and therefore samples are independent, we apply this test statistic f equal to ratio of sample variances, and here we consider nu1 equal to n1 minus 1 numerator degrees of freedom and nu2 equal to n2 minus 1 denominator degrees of freedom. We have discussed one question on F ratio test in lecture number 26 on hypothesis testing, and this is our second problem on the F ratio test. First we understand what is this question about. It is desired to determine whether there is less variability in the silver plating done by company 1 than in that done by company 2. If independent random samples of size 12 of the two companies' work yield S1 equal to 0.035 MIL, that is sample standard deviation for first sample, and S2 equal to 0.062 MIL, that is sample standard deviation for second sample. Test the null hypothesis sigma 1 square equal to sigma 2 square against the alternative hypothesis sigma 1 square is less than sigma 2 square at 0.05 level of significance. So here the variable of interest is the silver plating done by given company. There are two companies and they are taking two samples from those two companies, and both the samples are of size 12. So here we have n1 and n2 are equal to 12, and they are desired to determine whether there is less variability in the silver plating done by company 1 than in that done by company 2. So they want to check whether this variability in the silver plating done by company 1 is less than the variability in the silver plating done by company 2, and for that they are taking two samples of size 12 of the two companies' work yield, and they obtain that the sample standard deviations for those two samples are 0.035 and 0.062, and using this sample data they have asked to test this null hypothesis that two population variances are equal against the alternative hypothesis that population variance for company 1 is less than the population variance for company 2. So first we write down that sample size are n1 n2 equal to 12, and we are given values of sample standard deviations. What is S1? S1 is 0.035 and S2 is 0.062. They have already set null and alternative hypothesis. They are given in the question. Null hypothesis is to check whether two population variances are equal, or we can say that the silver plating done by company 1 and company 2 have same variability, and against the alternative hypothesis that there is less variability in the silver plating done by company 1 than that done by company 2, and because we have less than sign, this is going to be a one-tailed or left-tailed hypothesis test. and we will assume that this null hypothesis is correct or true, and we are going to test this null hypothesis at alpha equal to 0.05 level of significance. Now it is not given that populations for both the companies are normal. They have given that samples are independent. If independent random samples are selected from both the companies, so that condition is given. So we can write that given that samples are independent, given that two samples are independent, and it is not given that populations follow normal distribution, so we can assume that populations from which these two samples are drawn, so here populations are going to be company 1 and company 2. So we assume that populations are normal. To apply F ratio test, we must check these two conditions. If any of these two conditions is not given, we have to assume that condition. Otherwise, we cannot use that F ratio test. So with these two assumptions, we find out the value of test statistic. So we know that capital F is equal to S1 square over S2 square. This ratio follows an F distribution with nu1 equal to n1 minus 1 degrees of freedom in the numerator, nu2 equal to n2 minus 1 degrees of freedom in the denominator, and here n1 and n2 both are 12. Therefore, we have 11 degrees of freedom in the numerator and 11 degrees of freedom in the denominator, and we are given values of sample standard deviations, so that we substitute here. S1 is 0.035, S2 is 0.062. So let me substitute these two values, 0.035 for S1, 0.062 for S2, and if we simplify this using scientific calculator up to 5 decimal places, I obtain these values for the sample variances, and if I take their division, my answer is 0.32031 for the calculated value of test statistic. So if we round off up to 2 decimal places, we have 0.32. This is calculated value of test statistic. Next step is to determine the critical regions. So for that, we notice that we are given a left-tailed test, and level of significance is given as 0.05, and because of this less than sign, we have one-tailed test. Therefore, we will consider 0.05 area in the left tail, and we are familiar with the probability density curve for F distribution, and let me just roughly sketch that probability density curve for F distribution. F distribution always takes non-negative values, and here we have 0, minimum value is 0, and let me roughly sketch this graph of F distribution. It may look like this. It will have longer tail on right side, and this will never cross x-axis. It will go parallel to x-axis, and here we are given that we have sigma 1 square is less than sigma 2 square. Therefore, we have left tailed test. So we consider this area equal to 0.05. Area in the left tail is say 0.05 5 because level of significance is 0.05 and we are considering values of random variable f on the horizontal axis. So first I have to decide what is this point. So we know that the point on the horizontal axis is critical value of f if area to the right side of that axis is given. For example, if I write f alpha point on horizontal axis, then f alpha is that value of capital F such that area to the right side of f alpha is alpha. So here first I have to decide what is the area to the right side of this point, and we know that total area under the probability density curve is always 1. Therefore, area to the right side of this point can be obtained by subtracting the area to the left side of this point, and that is 0.05. Therefore, we have 1 minus 0.05, that is 0.95 area on the right side of this point. So this point will be denoted by f suffix 0.95. Now how to find out critical value, which is this point? So we can see our f distribution is available for particular values of alpha, that is 5%, 1%, 2.5%, etc. But for this 0.95 we are not having f distribution. So for that we can use this identity f suffix 1 minus alpha with nu1 and nu2 degrees of freedom can be obtained by taking reciprocal of f alpha with change of numerator and denominator degrees of freedom. So here I write denominator degrees of freedom and here I write numerator degrees of freedom. So I am interested in the value of f suffix 0.95. Here degrees of freedom are same, both are 11. I can rewrite 0.95 as 1 minus 0.05. I am writing in this form 1 minus something. So to use this identity we can compare this with 1 minus alpha and we can see alpha is 0.05. So here I can write this as 1 minus 0.05 equal to 1 divided by f suffix 0.05, and here I have to interchange these two, but both are same. We have 11 degrees of freedom for numerator and denominator. So here we have 11 comma 11. So in the f table, first I have to search for alpha equal to 0.05. I have to find out the page of f distribution which corresponds to alpha equal to 0.05 or 5% level of significance, and then I have to check for numerator degrees of freedom equal to 11 and denominator degrees of freedom equal to 11. So now I am searching this value in f table. So let me open that statistical tables for f distribution. Just a minute. So I have to search for f distribution and for 5% level of significance. So you can see these are the critical values of f for 5% significance level, that is alpha equal to 0.05, and we are interested in the value f suffix 0.05 for 11 numerator degrees of freedom and 11 denominator degrees of freedom. For denominator degrees of freedom we have 11 here. This left column corresponds to denominator degrees of freedom. So we have 11 here. So we have to search in this row. But for numerator degrees of freedom there is no 11 here. After 10 we have 12. So what we will do, we will find out the intersecting points of these two columns corresponding to 10 and 12, and we will have two intersecting points. So we will take average of those two intersecting points to find out this critical value. Here nu1 is 11 and we are not having 11 in the table. So we are taking two neighboring points of 11 and we find out the corresponding points of intersection with denominator degrees of freedom, and we will take average of these 2 points as our critical value. So I have to take average of these 2 points. So let me remove these lines now, and you can see I am having 2.85, that is for 10 degrees of freedom in the numerator, 2.79 that is for 12 degrees of freedom in the denominator, and both corresponds to 11 degrees of freedom in the denominator, and I am taking average of these two, 2.85 plus 2.79 divided by 2, and this turns out to be 2.82. So remember, whenever you are not having corresponding numerator or denominator degrees of freedom, you can use nearest value to that degrees of freedom, and then you can take average corresponding to those 2 points. So here 11 is not there in this numerator degrees of freedom, so we are taking 10 and 12 and we take intersection with nu2 equal to 11, that is denominator degrees of freedom, and these 2 points we found in this table and we take their average. So here I will write this as, I can write down that 2 points first here also, 2.85 plus 2.79 divided by 2, and the average is 1 divided by 2.82, and this is equal to 0.35461, and if we round off up to 2 decimal places we have 0.35. So what we have obtained? We have obtained this critical value f suffix 0.95 for 11 degrees of freedom in the numerator, for 11 degrees of freedom in the denominator. And here we can mention that using F table, and the critical value is 0.35. So let's determine rejection region using this. We have this value is 0.35, and the region which is to the left side of this point is rejection region, and this region is non-rejection region. Now we compare this critical value and calculated value of test statistic, which is 0.32. So 0.32 is less than 0.35. So we can say that 0.32 might be somewhere here approximately. This is calculated value of test statistic, and it is less than this critical value, which is 0.35. That means we are in rejection region, and this shows that we must reject the null hypothesis. So we can write here also, here capital F is 0.32 and it is less than this critical value f.95 equal to 0.35. This means therefore we must reject the null hypothesis. And what is null hypothesis? Null hypothesis says that variability in the work yield or silver plating, variability in the silver plating done by both the companies are same, but we reject this null hypothesis. The conclusion is that we are rejecting the null hypothesis. That means we can say that there is less variability in the silver plating done by company 1 than in that done by company 2. So the sample data support the connection that the plating done by company 1 is less variable than that done by company 2. Here we are writing that we must reject null hypothesis. This means we can say that the data support that the plating done by company 1 is less variable than that done by company 2. This was our alternative hypothesis, and using F ratio test, our conclusion is that we must reject the null hypothesis. So we are rejecting this null hypothesis. That means we can say that the data support the alternative hypothesis. Alternative hypothesis is that there is less variability in the plating done by company 1 than that done by company 2. So this is another problem on F ratio test. You can see it is very easy. You have to search for sample size and sample variances, and remember this test statistic formula. And because we are having left-tailed probability of 0.05, we have to use this identity to determine this critical point. And after that we compare calculated value of test statistic with critical values of F distribution, and if we are in rejection region, we reject the null hypothesis. So here calculated value of test statistic is 0.32, and it is less than this 0.35, which is critical value. Therefore we are in rejection region, and therefore we reject the null hypothesis. So in this way we can answer this type of questions using F ratio test for the equality of two variances. So this is all about this session. I hope you like it. Thanks for watching.